This conference will now be recorded.
Good afternoon, everyone. Thank you for joining us for our webinar here today. Is my volume okay? Can people hear me? Just give me a thumbs up. Thank you very much, Tom. Want to thank everybody for joining us for our webinar on continuous resin-based 3D printing today. We're excited to have several special guests here to talk with us today. My name is Michael Story. I'm one of the owners here at Beckett Solutions. On with the line with us is my colleague, Matt Prey. Beckett Solutions is a full-service 3D printing solutions company. I just want to, before we get started, I want to remind everybody we have muted all the participants to start. We will have time for Q&A at the end. That said, if you have any questions during the demonstrations, we'll be keeping an eye on the chat and we'll be able to jump in with questions. Our experts will be able to answer questions throughout the webinar. So please feel free to leave them in the chat and we'll address those as they come up. For now, feel free to change your view to who's talking. You can access that setting along the top. You'll see a drop-down menu. Right now, it might be set to view everyone. If you set it to view who's talking, the camera will jump to the person that's talking. So we'll have a few different people talking here today and showing demonstrations. You'll want to be able to see that in your full screen. So again, Beckett Solutions is a full-service 3D printing company. Besides the brands we're going to talk about today, Beckett Solutions represents several renowned brands, including Ultimaker, Desktop Metal, Centratec, and 3D Platform, various 3D printing technologies. In this webcast, however, we're excited to talk about cDLM 3D printing, or continuous digital light manufacturing, an affordable, high-speed, resin-based 3D printing technology. Our experts are going to discuss this technology and showcase numerous applications, and we're actually going to see one of our experts setting up a print on the EnvisionTEC Envision 1. To that end, our partner in this technology is EnvisionTEC, an industry-leading manufacturer of DLP, cDLM 3D printers. EnvisionTEC is represented here today by Robert Montez. Robert is an applications technician and has a wealth of knowledge in the additive manufacturing space. Robert is going to walk us through some of the benefits of cDLM 3D printing and give us a deep dive on the technology. Robert is also going to walk us through the EnvisionTEC process, including a live demonstration of the Envision 1 3D printer, both setting up the print, letting it run, and then taking it off afterwards. So you'll want to make sure to stick around till the end because Robert's going to be taking the prints off the build that we print today. Later on, though, we're going to hear from Tom Lopez and Andy Scott of Henkel, a manufacturer of 3D printing materials, among others. They'll be talking about some of the unique and differentiated materials Henkel is bringing to the 3D printing market. With that said, I want to turn it over to Robert Montez of EnvisionTEC. Robert, take it away.
Thank you, Michael. Like you said, my name is Robert. I've been with the company for several years now. I am a lead Envision 1 technician here. Just want to give you guys a little bit of background as far as EnvisionTEC. We've been in the 3D printing space for a bit over 15 years, probably pushing 18 years. We started with the DLP technology, starting off with hearing aids, stuff like that, and then we started tapping into multiple other industries such as dental, industrial, jewelry, and I feel like we're a leading member in those groups. So specifically, I'm going to be talking about the MCAT, or industrial technology, that we're going to be doing. So like I said, starting off is DLP technology, very similar to SLA technology if you're familiar with that. Only difference is SLA is laser based, so it's a little laser pointer going around that highlights all the different parts. DLP is much faster, better resolution, because instead of going around each individual part, it does one full projection into the photosensitive polymer. So it does a layer by layer printing. So it cures to the film and build platform, slowly separates, comes back down. So that's what our main technology was for several years. But now we're bringing in, like Michael brought up, cDLM technology. cDLM is a continuous digital light manufacturing. So what that does is it's still DLP based, where it shoots the projector up, but instead of it slowly peeling away from the film, there is no film. It's a special membrane that we call a domeless material tray. So there's a film at the very bottom that permeates oxygen. So instead of separating from the film, we separate from oxygen. So think basically nothing. Think about an air hockey table, very similar as how that works. So since we're peeling away from nothing, we don't have to slowly peel away from anything like that. So it moves much, much quicker. So we can get much better resolution because there's not aggressive separation forces. And we can overall just get print much faster. So that's where the Envision 1 comes in. Envision 1 came out a couple years ago, and it shows off our patented domeless material tray. So cDLM is a rising technology in the 3D printing space. The only problem is when you pump oxygen into it, it fills it up like a balloon. So you get a dome effect. So that's why we refer to it as a domeless material tray, because this is the only one in the industry where it's perfectly flat. Benefit of that being is if there is a dome, you have to compensate for that, or your only accurate area will be in the dead center of the material tray. With the domeless material tray, you can print anywhere you want on the material tray, and it will always be 100% accurate. So showing off the Envision 1 3D printer, just take it straight out of the crate, throw it right on the table. It should be plug and play. Besides, obviously, the software I'm going to be showing you guys in a little bit. You can see we have the build platform here that detaches. This is where all the parts are going to be printing. Underneath, we have the material tray or the VAT system. This is where all the liquid polymer is going to be sitting in. The platform's going to come down. The projector inside the printer is going to be projecting up, and it's going to do layer by layer printing. There will be slight up and down motions, but it's much, much quicker than you'll see on other DLP or SLA-based technologies. There's a special feature with this, though, of course. We talked about cDLM technology. The only way we can get that is with oxygen concentrator that comes with the printer. So it's similar technology you would see that your grandparents or parents are hooked up to. It's a medical grade device that pushes out oxygen into this material tray. And like I said, permeates through that film, creates a nice bed of oxygen. So when we get it all set up, plugged in, I already have a job on here, so I'm going to start that. Just easily go into job list, make sure our hood is closed. I'm going to scroll down my list, select the job. I can rotate it around to look to see what I'm printing. Gives me an estimated print time of about 30 minutes. So I'll hit play. It's going to start the countdown. If I don't want to start it now, I can start it later. Say I want to print in the middle of the night, delayed by 12 or so hours, and it'll start around then. So while that's printing, I'm going to go ahead and jump into the operations. So how we actually set up the jobs in the software.
Robert, what software do you use for the Envision 1?
So this is our own software. This is the Envision 1 RP. It's a very strong software. It allows you to import your models. It's going to look through the whole model, and it's going to look at every single triangle, because the files we use are STLs. So they're made up of multiple little tiny triangles. So if I actually zoom in, you might actually see a few of them. You can kind of see the pixelation on how that works. So it's going to look through every single individual triangle, make sure that there's no errors in the parts. And if there are errors, like there's holes or overlapping triangles, it's going to fix it for you. So you don't have to use any sort of third-party software. So this is the job I just started. You see it's an articulated snake. So I should be able to just rip it right off of the platform, and it should already be articulated. You can see, if you can't see my webcam right now, I already have one printed, and it comes right off of the printer just like that. But for now, I'm already printing this one, so I'm just going to delete this and get rid of those. So whenever we start a new project, or whenever you start the software, this is the screen you're going to be seeing. Talking about creating a new project. So you can select whatever printer you have on the network. You can see I already have one selected, but you can also see all the other ones we have at our facility. If you don't have it on the network, you don't have to worry about it. You can do a virtual printer, so you can select any virtual printer. This is just a virtual space that you can play in. So if you don't have, say a whole network set up for your printers, you just want to print just offline, you can do that. So you just select one of these. So for Envision 1 Virtual, but in this case, I already have one, and you can actually see how much time is left. So you can actually see all the active printing. So the one I just started right now has 29 minutes left, while another one that we have further down, it's doing some testing, is 7 hours. And then if we wanted to pick up another one, we can see any other ones also on the network that we don't have selected. So I have that selected. Next would be the material. I can select whatever material. In this case, I'm printing the Urgiform Amber. It's one of our MCAD materials at a voxel depth of 100 microns. 100 microns is usually a base for most of our materials. It's very material dependent. Some of them we can do 50 microns, and all that is the actual layer by layer thickness. So 100 microns is about the thickness of a piece of paper. Some resins can do 50 microns, which would be a higher resolution print, but it's slower build time. So it's whatever you're kind of aiming for. So I can go ahead, if I want to upload new ones, I can, or if I want to rename them, or we also have training videos that'll show you how to get it done. So I'm going to hit create. So now it's going to show our build envelope. So basically anything we can fit on this platform, we can print. No matter how many models you put on here, it's still going to be the same amount of time. It's all dependent on the actual height of it. So I'm going to grab a little file that I have on my desktop, just drag and drop it. See, it says loading and healing. Like I said, it's going to be looking through the whole model, making sure that everything is fixed in there, and it's going to load it up. So I'm just rotating around with the right click, and I can pan with the mouse wheel. I'm going to zoom in on it so we can evaluate the part. You see we have a little part interface here with all the different circles. I can rotate along the different axes. Or if I wanted to go back to where I was, I can just hit Control Z. Oops. All right. Next icon we have is a compass icon. If I click and drag that, I can drag it around the platform. Little arrow with a line. If I have a flat base and I want to print off of it, I can just left click and hold, and wherever I let go, that'll make it the down facing surface. So if I want to make that flat, I can, and I can verify that it's flat because it's highlighted orange. If it was off, it would show whatever is actually touching the platform. So best practices for 3D printing, typically you want to grow with the model. So what I mean by that is, especially these teeth, we don't want any of them facing down because we'd have to support all of them. So I'm going to have them go off to the side, and the printer does a really good job of picking those up. Now, if I wanted to slice some of that off, if I wanted to make a flat bottom, I can select this tool, swipe it up, and wherever I let go, it'll slice the model right there and make that flat to the surface. But in this case, I want everything in there. I don't want to cut any of that. But I do want a few of these for my friends and family, so I'm going to make a bunch of copies. I'm going to go through and make the duplicates of them. Now, obviously, it won't print just like this. I will need to add support. So if I go ahead and select this tool, we have a whole list of supports that we can use. I'm just going to go ahead and select this one at the top because this is the one I've been messing with the most. We have full capabilities of modifying all of these. That's why I have that work for me. We also have a deeper advanced section where you can modify all these tools to make the supports exactly how you want them, changing the tip thickness, the beam thicknesses, the spacing, everything like that. Basically, the whole thinking logic, you have full access to modify that. Or if you don't want to bother with that, you can easily just use our default settings. So it does a really good job at supporting those. You can see it does a good job. It doesn't put any supports in the teeth because that would be a pain to try to clean off, but it'll grow just like that perfectly fine. So now I can actually look at this at a layer by layer perspective by selecting the eyeball icon over here. This helps it when you're supporting a model because it will actually show you where a little island will pop up. That's what we call like it's just a floating surface that needs the support but doesn't. So we can actually look at it layer by layer to evaluate the part, make sure there's no anomalies that we want to take care of. So that's all good. Next up, we have the layout option that we can use here. This, we can set a default number. We can say 5mm spacing and hit place all. It will grab all our parts and organize them on the platform for us so there's sufficient room. And it'll rotate them around and make sure we're using up the most space possible. So if you just loaded up a bunch of models, just supported them, you can just hit that and it will orientate all of them. There's also several other tools that we can manipulate, such as the newest labeling tool. We can actually use this to label the individual parts. So if we wanted to put name of our company, name of a patient, or whatever industry you're in, you could type it in there and label the part. You can either go into the model or you can either extrude from the model. So overall, we try to make the software as easy as possible with as little options as possible. So even just like a small startup can use the software and not struggle, while also advanced users have the ability where they don't feel limited and they can play around with the software a little more. So on the right-hand side, we have print time, the estimated print time. We can also calculate costs based off of the amount of material used and the actual material costs that you pay for.
Robert, if you had, sorry to interrupt, if you had very little experience with 3D printing, how quickly could you get up and running with the Envision 1 and software?
With our customers, we usually set up an install period. So like we call them, we walk them through the install. We do it all remote. especially now in these times, but we did it all remote before anyways because it's super easy. We get it up and running usually within the hour, and then all the extra is just playing around with it, just making sure they're all good. But we actually have a really good resource that we launched a few weeks ago. It's the Help Center or the Support Center, and you can find that at help.envisiontech.de. It's a one-stop shop for everything. It has all the support documents and just training for the printer, the software, the accessories, basically everything that you'll ever need. But so we can use that as a reference, and there's also several documents that come along with the printer. So whatever you feel more comfortable with, if you'd rather have the documents or if you'd rather have a whole support center, we have those options available. But for the most part, we see various size shops running these printers, even like specifically like dental labs. We see small mom and pop like shops running these, while we also see large production corporations that are running these printers. So there's, and anything in between really. So set this all up, ready to go. If I just hit print, if we wanted to change the printer, we can. You see it's 21 minutes left. We can set as many jobs as we want on the printer. We just gotta keep in mind it still has a computer on board, so we don't wanna crank it full of terabytes of memory. So if we can delete them, we can. So I can just name it whatever I want. So in the dental space, you will name it after patients, or in industrial senses, you would name it based on case by case. Just call it that, go off the date, just send job to printer. And that's just because I saved it to a drive that doesn't exist anymore. And then it'll go through layer by layer and it'll evaluate the print job that we just created, making sure that there's no errors or anything that it missed. So it's checking it layer by layer, making sure there's no missing, and it's making sure that it's going to print successfully. And you see how it's actually going to be printing layer by layer. Now, print time is very dependent on material. So different materials will print at different speeds. Some will print faster, some will print slower. And it's all based on the actual application, which we'll be getting into here shortly. And then, of course, the job upload. This is going across the network, so it depends on your network speed. As you saw, we have several printers on the network, so speeds may vary. But yeah, for the most part, that's it.
So is the Envision one, is it wireless, Robert?
Yep, so you can do hardwire, you can do Wi-Fi, you can just do off of a thumb drive, which is what I did right there. That's why you saw that error before, because the thumb drive no longer exists. But yeah, there's multiple different options to try to fit whatever you need. So it really is dependent on what works in your environment. Yep. So you can see, finish that off, so I can easily just start the next job and transfer it to the next printer, and so on and so forth, and just keep going.
Hey, Robert, we had a question come in.
Yeah.
How many materials are available for the Envision one? Now, I know that there's well over 100 materials that EnvisionTEC offers between the materials that EnvisionTEC manufacturers and partners. But for the Envision one specifically, how many materials, and then how many of those are MCAD materials?
So that's a crazy list. So there's a pretty good number of materials, and we're constantly coming out with more and more. You can find them all on our website, and especially we got Henkel on the line. They'll be talking about it a little more, and they cover most of our MCAD space as far as the resins. So it's really whatever application you're looking for. In this case, I was working with the Rigid-Form Amber material. This is very good tensile strength, very good high impact resistance, but that might not be the right material for you. So it's really trying to figure out what you need, but there's a lot of materials, and we're constantly coming out with more and more, as well as looking at third parties to bring in their resins, which is instead of you having to try to troubleshoot and figure out how to get these resins to work for you and potentially messing up your equipment, we're doing all the work for you. So we're constantly looking at different applications, bringing in more and more resins to make it work. Right. Speaking of resins, so like I said before, we touch on a lot of different industries, biggest ones being dental and MCAD, or industrial prototyping. So speaking of medical, with COVID this year, lot of resources were limited for a lot of companies. So a big thing that we did, that we jumped on, was actually printing the NP swabs for the COVID test. So that was a big thing we did the majority of the year, just printing the swabs in our materials that we manufactured. Specifically, it was our eGuide soft material. I don't know if we want to do that. As you can see there, very, very small. It was especially designed by our team to make sure it collects correct amount of specimens for the test, and just we're able to print a ton of them at a time, about 400 of them within about 5 hours or so, and just constantly printing those out. And not only us, but our customers were as well, if they qualified for that FDA approval. So tons and tons of swabs are printing in the medical field. So a lot of medical offices have our printers. As well
So
as,
Robert, can those swabs be printed on the Envision One?
yeah, they're specifically printed on the Envision One. Yep. That material was specifically engineered for the Envision One.
And didn't I read something a few weeks back about you guys have between you, EnvisionTEC, and the partners, you've successfully printed 1 million COVID-19 swabs?
Yep, yeah, definitely. We were working 24/7. We had several different shifts working printing these swabs, as well as our customers. They printed numerous amount of swabs, and they did a really good job too.
So those files are available to customers if they get the FDA approval. They could start printing those swabs as well. Then.
Correct. Yes. Yep.
That's great.
I just want to jump in for a second. It was definitely well over 1 million. We had several orders that were each one over 1 million. So
Yeah,
that's fantastic. Thanks.
All right. Yeah. And besides just medical, we even work with like the entertainment industry, working with figurine companies, toy companies. So you can see pretty high resolution parts printed on the Envision One, as well as even using some of the Henkel resins for this as well. That was just the Raptor head that we're just playing with. This is the E-rigid form charcoal. This is similar to the one we're just printing with right now. This is just the darker version, while the amber is amber color, you can see. But very, very strong resin. Same thing with this one's charcoal. Very strong. But like I showed before, in case you didn't see it that well, this is what it's printing currently right now. It's the amber. This is before curing. This is taken right off of the printer. You just take it right off of the supports and it automatically starts articulating. So like I mentioned, we're working with a lot of different companies to try to develop different resins that fit the customer needs. So Henkel is a big one that we're pushing in the MCAD space just because of the vast amount of materials and all the different applications that they cover. So that's where Tom Lopez and Andy Scott here could probably elaborate a little more on.
Yeah, thanks, Robert. We'll turn it over to Tom and Andy at this point. They're going to talk about some of the unique and differentiated materials that Henkel is bringing to the 3D printing market, specifically with the resins. I want to ask you guys if you could touch on, I know we have a lot of customers in the manufacturing and MCAD space here, so if you could touch on some of the specific applications for those industries, that would be super helpful. So turn it over to Tom Lopez and Andy Scott from Henkel at this time.
There we go. Sorry about that. Typical errors that happen when you're presenting. But my name is Tom Lopez. I'm a business development manager for Henkel Technologies. We also go under the name Loctite that most people recognize. I'm joined here today with Andy Scott, who's our TCS scientist associated to help and support with applications. And just kind of a brief overview, Henkel, you may or may not know the name, but Henkel has been in business for over 100 years. But we're actually, names that you may recognize under our wing, Dial Soap, all these other companies. But we're a special wing of the Henkel family that is devoted to advancing the technology in additive manufacturing, not just the production of prototypes and jigs and fixtures, which are all an important part of it, but actually developing materials that have true end-use function, materials that you can utilize to print parts that have end use that can handle environmental exposure or impact. You know, we know the future is additive manufacturing. It's got such a great place in the world, but that's what's been lacking in the marketplace as we see it, is materials that are truly differentiated that can be used for a variety of different things. So that being said, Andy's got a little bit of a throat issue going on. Fortunately, it's not the issue we're all afraid of. So his voice isn't 100% there, but he'll chime in to help and support as we go. But one thing that's important with materials and with printing, and it's an understanding that needs to be that it's a process. There's kind of a workflow that needs to work together, and that's really why we're super excited with the partnership with EnvisionTEC. Is not only do they have, you know, the technology to print our materials, but they're also known as the leader in the industry with their cDLM technology. So that being said, we publish a technical data sheet, and you can find these technical data sheets on our website. I'm not sure what you're seeing right now because okay, I guess you can. This is our website at loctiteam.com. And on this website, you know, we're not going to go through every page, but you can look at our different materials, the markets that we play in, but you can also download a technical data sheet. Now, a technical data sheet gives you all the information you need on the properties of the printed material if, and that's a big if you follow a workflow to properly print the product. So when you print a material, printing is only one aspect. Then you're involved with post-processing. So the part needs to be cleaned, it needs to be cleaned properly, and then it needs to be post-cured to get the true properties of the material. And if you don't do things right, it's not going to match up to the specifications that are on the technical data sheet. And that's critical. So we want to ensure, you know, and I use this term, and hopefully it's not offensive to everyone because I consider myself part of the camp. Back in the day, when you tried to print something, you needed to be a true propeller head to figure this kind of thing out. You needed somebody that was a wizard and part, you know, scientist, part magician, part artist to get a print to print correctly. We're trying to eliminate that by providing what's called a dedicated workflow. And a dedicated workflow gives you exact instructions on how to get the end results. So one thing you obviously need is you need a printer and you need the right material, but you also need that instruction. So I'm going to take you through, on our website, you can hover over the printer workflow, and you can click on find your printer settings. And this is again on our website at loctiteam.com. So what you would do is you would select your printer, which is the EnvisionTEC. You would select the material, and these materials all have validated workflows where EnvisionTEC has worked on developing the printer settings. We have tested, and if you follow the workflow, you're going to get that information that's on the tech data sheet. So I'm going to select one here, 3843, which is a HDT of 60, heat deflection temperature of 60, is a true hero product. Select the color, let's go with black. Select the cleaner you want to use. Now, the industry traditionally uses IPA. We also manufacture a cleaner called Cleaner C, which is much safer in a production environment. Again, if you're going to go into true additive manufacturing where you've got, you know, 10 printers running and cleaning going on of all these parts, using IPA in a production environment can be a bit of a challenge due to the flammability. Cleaner C is a good option. There's information on that on the site, right? So we'll select, say, IPA, because that's what the industry generally uses, all right? Select IPA, and then we'll select a Loctite curing chamber, our CL36. And then when you click on the PDF, it's going to generate everything you need to properly print and post-process the part. Again, we can make the materials, but if you don't follow the steps, you're not going to get those true end-use properties that we publish on the data sheet. Again, we're trying to make materials, and we are making materials that have true end-use function, from bouncing around in the back of a pickup truck for an industrial application in Alaska or in Arizona. You know, these things have end-use function, but if you don't print them correctly and post-process them correctly, you're not going to get that information. All right, so it'll take you through the bill layer settings. You know, the part cleaning. You know, this is just a stirring model with a orbital shaker. But wash cycle 1 using IPA, 5 minutes at 23C, agitate the material, and then, you know, it doesn't need to dry, but then run through a second wash cycle, 5 minutes at 23C with no agitation, dry time of an hour, and there's some notes down here on the bottom. But again, if you don't dry that part long enough and let that IPA flash off, it's not going to give you the results that are optimal for that material. So again, we're trying to take the guesswork out of 3D printing. You know, I mean, we want people to be able to, part 1 on day 1 of Monday comes out exactly as, you know, the final part on the end of Friday, right? Take out that guesswork. So that's very, very critical, right? Now, speaking of workflows, we publish workflows for the different types of printers, and they're certified by Loctite. We have validated workflows, but this gives you an idea with EnvisionTEC of all the different materials where we've got workflows and the ones that don't work well, right? We, you know, in the background, I know EnvisionTEC's working on this, and it's going to happen pretty soon. We have a material that is qualified for fire, smoke, and toxicity. FST material, and it's a solid at room temperature. Therefore, the material needs to be liquefied at 60C or greater and printed at 60C or greater. But again, we'll publish all this information. It's updated daily because we're constantly bringing new materials to the marketplace. So we want you to go in understanding, you know, as well as EnvisionTEC helping and supporting as well, is, will this material print? Does it meet the properties that I have? And how can I do it and ensure success? Because nobody likes a failed print. You know, when you're building a part that's very tall in Z and it fails way deep into the print, that's not a lot of fun. So nonetheless, we're working very hard to make it easy for people to print. Now, we have a brochure that lists a lot of our great materials. And you can download this from LoctiteAM.com, but it talks a lot about our different materials. It talks about what was spoken to earlier with respect to the different types of printing, from FDM, you know, all the way to DLP, where we play. And we feel that, you know, technically, as a materials company, we could have developed materials for any of these different technologies. However, DLP is the future, the ability to print an entire layer at one time, but also with the cDLM technology to be able to, you know, quickly remove it, you know, and start the next layer is very, very critical, right? So again, our literature is very comprehensive. It will list a lot of our different materials that we manufacture, from what we call photoplastic materials and photoelastic materials. We have materials that are elastic in nature, some are silicone based, and some are acrylic based. Again, a lot of these have end use functionality beyond just jigs and fixtures or prototyping. So I encourage you to go to LoctiteAM.com and take a look around, and I'll pass it to the next presenter now, and we'll be available to answer questions as we roll along. And if there's any questions now, we can knock them out too.
Yeah, hey Tom, I'm going to actually put a link to download the material solution guide for additive manufacturing from Loctite in the chat here, so people will be able to go ahead and download that right now if they want, save a copy, and then we'll be sure to send that link to all the participants here today, so they'll be able to easily access that guide.
Fantastic, thank you.
You're welcome. Hey, Robert, how we looking with the print over there?
It's looking really good. We have about 2 minutes left on it, so it's almost
Okay,
there.
well, in that time, do you mind talking about some of the specific materials that would be used in manufacturing, and then some of the specific applications, like jigs, fixtures, injection molding tools, and the like?
Yeah, definitely. So I'm actually bringing up our website right now because I'm going to reference some photos on our website just to make it easier for everyone at home. All right, so actually on our website, you can go into the materials. So we want to get specific with it. We want to look at the Envision 1 because that's what we're talking about today. Looks like my connection's a little slow. Let's see if I can just click right into it. All right, here we go. So you can see a whole bunch of materials, and if we click into any of them, so let's just click into, we'll look at the FST one, just like Tom was talking about. So if we click into it, we have technical data that he was referring to. It goes over all the chemical properties of it. So like you said, this one is very, very close to being complete. We're actually stress testing it. If behind this wall, we're testing it right back there. So very, very high heat resistant material. And it kind of goes over a little like the application that you would use. Like you would see this in like the aerospace industry, stuff like that. And just going through all the different ones, we have materials that you can use as masters for different applications. You can use some of these for making molds. Basically, we want to eliminate the expensive tooling that's needed to do prototyping, stuff like that. So you can easily mock up a prototype of any sort of part. Like if you can see in my camera, like this part in the instance, it could take a very, very long time to machine it, while it would only take like a couple hours to print on the printer. And if you don't like it, you can easily modify it and make another one. Also under the Loctite line, we have very flexible materials like shoe sole, like rubber-like materials. And it really just depends on what you're trying to look for. We have high heat resistant materials. We have some that are a little more flexible. Like we recently designed and printed a drone frame. So there's a lot of different applications that these could fall under. And like I said, the dental materials that we also print. And then it looks like, actually, if you can see behind me, if I actually stop this screen share, the parts just printed, came all the way up. You can see them sitting on the platform. So I'm going to go ahead and take those off. Open the hood. Grab some paper towel because it is a liquid in its green state. We don't want it dripping off. See it. You see the printed right on there. And I'm just going to take it off the supports. Oh, the supports came off with it. Came right off in one piece. So they're not stuck on there, cemented. You don't need to hammer them off. You should be able to just take them off even with your hands. And
It's
like I
pretty
said,
simple.
yep, already articulated too.
So then what would be the step to finish? So you mentioned these are in a green state right now. What would be the step to finish these if you wanted to complete the process?
Yep, very good question. So they're still wet. They're very shiny still. So we want to get that excess resin off. So Tom mentioned it slightly, was the IPA, or isopropyl alcohol. We use 99% typically. You can use anything higher than that. Just submerging it only takes a few minutes to clean most of the materials. So we sell a parts washer that you can purchase with in addition to your Envision 1, or even if you have some sort of agitator, stuff like that. Just agitate it around in there for a couple minutes with compressed air, just drying it off. Or if you don't want to use IPA, we also have, it's called PC1. It's more of an environmentally friendly cleaner. You can use that as well. It's a similar process. You just need to dilute it and just have it wash in there for a few minutes. After that, you put it in any of the certified curing units that we sell or the Loctite cell. And again, just several minutes. Doesn't take too long. We should have the whole process done within the hour, hopefully. But there are supports on this because it is more of an organic shape. So for the most part, you can just use the wire snips or X-Acto knives that we provide. Right now, I'm just tearing them off with my hand. And then afterwards, after we cure it and everything like that, we can just sand it down. And just, like I said, we're just trying to keep everything super, super simple. Tom mentioned, like before, it was very complicated. We want to do all that legwork. So you just get printing, get working, and because time is money. So we want to make everything as fast as possible and as efficient as possible.
So for support removal, you don't need any specialty equipment or any kind of caustic baths, chemical baths, or anything along those lines, do you?
Nope. Even if I took you back to my cleaning room right now, we just have some like Tupperware containers just holding the alcohol with a lid, and we just have a couple baths. We go through each one, and that's it. Just also any standard air compressor you can find at any store you can use, and yeah, that's it. You can get more, like you can get like rotary tools, like Dremels and stuff like that, but it's not needed. It'll just make your life a little easier. But starting off, you definitely don't need it. Like I already got most of the supports off just by hand, and then after I clean it and cure it, I would just need to sand it down just a little bit.
That does seem super simple. Hey, Robert, we've got a few questions coming in specifically about the Envision One. Before we get to those, I want to let everybody know I put some resources in the chat. I put a link to the materials page on the EnvisionTEC website. So you can link right there, and you can actually sort by category, specifically by printer, by industry, and manufacturing is right on there. Or if you want to look at a specific material, there's a drop-down menu for that. I also put a link to the help.envisiontech.de page, that support and page that Robert mentioned. It has all the training documents, support documents there. I put a link to, Jenna had mentioned what we did, what Robert and Jenna mentioned, what EnvisionTEC was doing with the COVID-19, so you can read through some of the efforts there. And then finally, a link directly to the Loctite AM website for people to peruse through there. So specifically on the Envision One, what is the build envelope of the Envision One?
It's good. So it's a roughly 180 millimeters by 102 millimeters in the X and Y, and then the Z height is about 200 millimeters.
And with the cDLM technology, how fast is it, or what's the speed? I know that's kind of a...
Yeah, no, it's very dependent on resin. So in this case, with the E-Rigid-Form Amber, it's about a 45 to 50 millimeter an hour print speed. And definitely...
how does that compare?
Oh, go ahead.
Sorry, go ahead. So how does that compare to other manufacturers?
Definitely probably one of the fastest. Other competitors that have the cDLM technology, I mentioned at the beginning, the domeless tray versus the non-dome tray. Problem with the dome tray is you need to actually compensate for it or move much slower or even press it down much harder. So that adds a bunch of time. So I would say our printer is the fastest, one of the fastest, if not the fastest printers on the market right now. And especially comparing it to just standard DLP or even SLA. Like we hear a lot of customers, they start with like the cheaper SLA printers just to get into it, but they quickly outgrow it. A good reference that I have is in the dental space, just printing normal aligners that are roughly, say, 30 millimeters tall. Customers printing SLA, 6 models. It took them 36 hours to print, while on the Envision One, it took 26 minutes. So it's definitely a big jump. So definitely very, very fast printer compared to a lot of other ones that are on the market currently. Plus, we're not sacrificing resolution with the build envelope.
That brings up a pretty good point. I won't name anybody specifically, but I think people are aware of the kind of the world leader in desktop SLA 3D printers. How does the Envision One and how does EnvisionTEC compare to this unnamed competitor?
So it's actually, I'm glad you brought that up. So that's specifically who I'm talking about. If you can understand that. So it's also, there's no aggressive forces with the Envision One that you see on a printer like that. So you won't get that stair stepping. If you know what I'm talking, if you're familiar with 3D printing, you'll know what I'm talking about. I can't really show it. You'd need a but I would need a better camera to show you guys, but it basically looked like stair stepping because we're printing layer by layer at 100 microns. So you would see just a very jagged stair step as it goes over a contour. So with Envision 1, that's not as aggressive because it's layerless printing. So it's a very smooth surface. You'll still get it ever so slightly, but compared to the much aggressive forces of other printers, it would be much more prominent. But yeah, so also on that topic, going in regards to material tray compared to other competitors, like I said, this domeless 100% flat, while one of the worst one in the industry is actually from, this is actually the material tray, have it for reference. From the center is going to have the highest point, and one of the worst ones from the corner to the dead center is off by 400 microns. So 4 pieces of paper stacked up, which is pretty aggressive. So definitely domeless is the way to go.
Yeah, if anybody has any specific questions there, feel free to reach out to us directly. Hey, Robert, this is a multi-part question. Is the Envision 1 office friendly? Is there any special power required for the Envision 1? Any special ventilation? Are there any fumes? Do you have to wear specialty glasses, laser blocking glasses when operating? Anything that would require it to be in more of an industrial setting?
Nope. So like I said earlier, you will see it in so many different industries. This one's literally right next to my desk. So if there's anything hazardous, then I would have been gone a long time ago. No, like it's literally just sitting right on my desk. We see them. I just was working with a customer. They have it in their garage because they're starting up a shop. But I also just left another facility where they're in a big industrial warehouse with several of these printers. There's no special precautions. I took the models off on my desk, just wearing gloves. As far as like protective eyeglasses for the laser, that's what this orange hood is for. This orange hood is going to block all that light out. Plus, how the print processes with that platform down in there, no light's escaping anyways. Especially if light was going to scatter around everywhere, you would have very terrible parts. So the light is very confined to exactly what we're printing. So you don't have to worry about any of that.
So as a follow-up to that, would you need to be conscientious of where you place it? Would you need to place it away from any windows, any place where the UV light would be able to get in?
Yeah, definitely. So as far as the environment, we want to try to keep it in a low traffic area because we are printing very, very, very small, so layer by layer. So we don't want it in a high traffic area where like high-lows and stuff would be driving around, shaking it all up. But this table is not even that sturdy, and it prints perfectly fine. So as long as it's on a sturdy surface, away from like steam, smoke, stuff like that, because the oxygen concentrator is going to be sucking all of that up. So just trying to keep it away from all those, but for the most part, you can kind of just drop it wherever and print with it. But yeah, we do want to try to keep it away from from the windows, especially ones that face like the sun, because this hood will block out most of it, but the sun can penetrate through and cure that resin. Especially, I don't know if you saw, after I finished the print, I closed the hood right away, even though I'm not using it, because over time, it'll take a while, but over time, the ambient light will cure that resin because it is photosensitive.
I know that personally. I was doing an installation of one once, and I left the hood open a little too long, and when I went to look in, the liquid photopolymer had started to cure right at the surface there. It happens very quickly.
Yeah, which it's nothing, you don't have to throw away the whole thing. You can just empty it out, filter it. We provide cone filters. You can just filter it out, pour it back in, and just keep rolling with it. And if you get any resin anywhere, even if I have some on my arm right now just from messing with this, I don't, it's nothing to be worried about. Just go wash it off, or I'm using paper towel just to wipe it off from any surface, and you're good to go. There are some specific resins that might need some special stuff, but you'll have all the safety data sheets or technical data on those sheets when you get the resin. That'll cover that, but there's nothing, most of the resins are fine.
Try not to ingest it though, right?
Yes, yeah, most, especially iridiform amber, doesn't taste good at all. So I wouldn't try.
Some of the materials will stain your clothing too. Just be aware of that.
Yeah, I was pouring some resin in there earlier, and I got some on my pants. So
no special fume. You don't need a hood or anything to run the printer. I know there might be a slight odor from the pouring the resin in, but it doesn't give off any toxic fumes or any particulates.
No, not unless otherwise specified. There's one resin that we're actually developing here soon, but as soon as you receive that resin, you'll get all the safety data sheets that refer like don't directly inhale the resin or don't ingest it, like you said. But no, everything. If there is any concerns, you'll be given paperwork ahead of time to prevent any sort of issue. But no, most of the resins that you're going to be working with are perfectly fine.
Great. Hey, Tom, are you still with us? We got a question for,
Yes, I am.
for the Henkel guys. Great.
Yes, I am.
So
Yep.
someone wants to know, Tom, how many materials does Henkel have currently for EnvisionTEC and for the Envision 1, and how many are coming up?
Andy, I'd like to defer that question to you. There's quite a bit in the pipeline. So are you there, Andy?
I'm here. Yeah, so as far as materials that are readily available for the EnvisionTEC and the Envision 1, we have roughly about a little more than a half dozen materials that are already approved, with quite an extensive pipeline that we're actively engaged with EnvisionTEC to get on. So just because the material's not showing up on the list today doesn't mean it might not be available tomorrow.
Excellent. And then a follow-up to that, Robert, someone wants to know, how difficult is it to change materials on the Envision 1, or are you stuck with one material once you load it, once you pour it into the build tray?
Nope. So we try to keep certain resins to the same material tray, just because some of them, especially like if you're working with silicone tends to be a little oily, so it might leave a residue. So we probably dedicate a material tray just for that. But for the most part, it's just using paper towel. You don't need any sort of cleaner or anything like that. Just like this one was used recently, and it was just wiping it all around with just a paper towel. Should be good to go. Just running another resin. We usually recommend having one material tray per resin, but for the most part, it's interchangeable. You just grab one, switch it, and then just empty it out, because we don't want to leave resin in there for too long. We say at the max probably 3 days, just because we want to get the most life out of the material tray. It is a consumable after all. So if you just empty it out, if you're not going to be using it, the tray will last much longer.
Yeah, I think that's good practice, is to have a material tray dedicated to a specific material, just to avoid any possibility of cross-contamination. But if you didn't want to do that, you can filter the material that was in the build tray into a clean bottle and reuse the filtered material. Is that correct, Robert?
Correct. Yes. We just try to keep whatever resin we're printing with in a separate bottle to avoid, like you said, any sort of contamination. That's why we try to keep any sort of chemicals out of the material tray, stuff like that, so we don't potentially compromise the rest of the material. But as long as you just empty it out, wipe everything down, you should be good to go.
Okay, well, it's about 5 till, so if you guys are okay hanging on for about 5 more minutes, any other questions? If anybody has any more questions coming in, please go ahead and send them over. Price of the printer fully loaded, as well as the resins, separated ballpark price list. Is that something that you can talk about, Robert?
I wouldn't have any of that information. I just deal with the
Yeah,
technical.
that's okay. So, no, that's fine. Well, we're happy to help you out with that. We'll go ahead and if you want to send me an email directly, I'm going to put my email in the chat, and feel free to send that, and I will send all the information over on the price list for the materials and the printer fully loaded. We can help you out with all of that kind of stuff. Someone wants to know, though, and I know the answer to this, but do you need to buy oxygen tanks for the O2 concentrator?
No, so it's actually a small concentrator that you can sit next to it or on the ground. Mine's a little too far because I have it wrapped around. But no, it's just a concentrated medical grade. I mentioned it earlier, but it's something like you would see your grandparents hooked up to, like something that they're going to be relying on solely for oxygen. So you don't need a tank or anything like that. It's just an electronic box. It constantly is pulling in the air, compressing it, and pushing it through the printer. It's just plug and play. As soon as you get it, you plug it in, plug it into the printer, turn it on, and you're good to go. You can leave it on for months. You can turn it off every night. It's up to you. The ones we have around the corner have been running for the past year because we're printing swabs with them, and they've just been running nonstop because they need to be reliable, because they're used for other purposes for the people that actually need the oxygen. So no, so you don't need to buy anything external. It comes with the printer, with the purchase price, everything like that.
Good to know. Yeah, you can the O2 generator, how heavy is that, Robert?
Oh, it's just probably like 12 pounds maybe.
Yeah. So I had someone wanted to know about the portability of the system. Could you move this around if you needed to from one office to another.
The Envision one, yeah. So yeah, we have people that constantly move from like one office to another. We just run preliminary, just calibration, just make sure everything is 100% before we actually start printing production. But that takes less than 10 minutes to do. So just yeah, you can easily the printer itself, I believe, weighs about 80 pounds, maybe a little less than that. I think I'm overkilling it a little bit. I'm pretty sure it's less than 80 pounds. So we usually recommend 2 people picking it up, moving it, but you can just throw it in the back of your car if you want to and take it to another location. But yeah, so it's super portable, especially like the concentrator is also very, very small. I can grab one here in a second just to show you guys.
Yeah, Robert, do you have the ability to take your camera and kind of show us a close-up of some of the not the features, but the parts of the Envision one?
Yeah. Let me situate them a little bit. There, give me 1 second while I move it around.
Yeah. Andy, Tom, anything else you guys want to jump in with? We got just a couple of minutes left. I wanted to kind of close with Robert showing us the printer up close.
Yeah, I'll just jump in with one additional comment related to Tom's presentations on the workflows. That just because, so if you look at the list of workflows and if you don't see something that specifically aligns with your production needs or what you have on site, it doesn't necessarily mean that it's not going to work or not compatible. We're always putting out new workflows and always working with customers in order to ensure that the material meets the data on our data sheet. So we're always developing and supporting the development of new workflows.
And I'd also like to chime in, thanks Andy, that we're evolving rapidly. We have many materials in the pipeline that I think we can share this. You know, we've been very good at materials. We launched into this effort. We came out with some great materials, but a few years back, we bought a company in Concord, California called Molecule, and Molecule is the company that's behind the majority of the resins on the marketplace that you see in the news for advancing additive manufacturing. So they're now a Henkel company. But what that means is we have the most innovative minds in the company producing materials. So we're not just a few materials coming out every now and then and running with it. We're constantly driving better properties and new things. So just, you know, you come back to our site next week and it'll be updated with new things. We're changing all the time. So watch out for us.
I'm excited to see what you guys come up with next. Robert, just let me know when you're ready, but I want to thank everybody for coming. After Robert kind of shows us up close, we'll go ahead and close this out. It is 2 o'clock, but thank you everybody for coming. I put our contact information in the chat. If you want to learn more about cDLM 3D printers, EnvisionTEC, and Henkel, you can go to our website. You can also email me or call directly. Robert, what do you got for us?
All right, so I'm just showing off some of the parts a little up close. Just so you can see them. I forgot to show this earlier, but you can see them now. These are the actual printed dentures. So everything you see right here is 100% printed. We have 2 tiers. We have our economy version of the denture and then the premier one. So this one's going to last you a lot longer. You can straight take these, put them in your mouth, and they're custom designed for each patient. So you can straight print all those. Just thought those were cool, and I wanted to share that with you. This is a 3840, one of Loctate's resins. And there's a little up close of the nasal swab.
Oh, that's good. That's cool to see.
So that's specifically designed by our team and shared with all our partners and customers that wanted to print the actual swabs. And that's just what I have right now on my desk.
Excellent. Well, it's good to see those parts up close. Thanks so much, Robert. If that's it, have any other questions coming in? Thank you everybody for attending our webinar here today. We're going to send out an email to all the participants with the recording, as well as links to all these resources we talked about. If you have any specific questions, you can go to our website or EnvisionTEC's website or Henkel or LoctiteAM.com to find out more information. Robert, thanks so much for your help. Tom and Andy, thanks for being part of our webinar here today. And thank you to everybody. Have a great afternoon.
How's it going, guys?